What if I told you that um, over half of your driving distance has absolutely nothing to do with your arms, like nothing to do with your club head, or even how hard you feel like you're swinging?
Yeah, I mean, it sounds completely backwards to how most people are taught to play the game.
Right. So today, we are proving that the modern golf swing is it's not an arm sport. It is
Yeah.
an earth-moving event based purely on physics.
Exactly.
Welcome to this deep dive, where we are unpacking a really fascinating stack of biomechanical research, PGA coaching notes, and wearable tech data. We're on a mission to map the exact blueprint that turns ground pressure into massive power and consistency for you.
And that's so important because the sheer volume of high-level sports science data we have today, well, it allows us to finally translate those subjective swing thoughts into actual mechanical realities.
Which is huge, because what a swing feels like to you, the golfer, is rarely what's actually happening, right?
Right, exactly. The human body is this highly complex lever system, and during a drive, it gets pushed to its absolute structural limits. Today is really about bridging the gap between that feeling and the literal forces at play beneath your cleats.
So to get right into it, why does this level of math even matter? I mean, we're pulling directly from this massive foundational study of over 300 golfers, high handicappers all the way up to touring professionals.
Yeah, and the researchers didn't just watch these swings. They applied some really complex regression models to the kinematic data.
Right.
And what they found was that just a few specific kinematic variables, along with ground reaction forces, account for, get this, an astonishing 44 to 74% of the variance in a golfer's ball velocity.
Wait, up to 74%. I mean, that is a staggering amount of your club head speed, just completely dictated by invisible forces.
It really is, and that data point fundamentally shifts how you should approach your practice. It proves that a tiny misunderstanding of how you move translates to massive losses in distance and accuracy.
So it's not about raw muscular effort at all.
Not at all. It's about precision in manipulating these invisible physical forces. Top pros execute these mechanics subconsciously on every single tee box.
But for the rest of us, by breaking down the science, you can understand the exact blueprint of a powerful swing rather than, just guessing on the driving range.
Exactly. And power generation starts at the absolute bottom of the kinetic chain, which brings us to the scientific foundation of all this Newton's third law of motion.
Right, Dr. Kwan's research on ground reaction force.
Yes. For every action like pushing into the ground, there's an equal and opposite reaction, which is the ground pushing back up against you.
Okay, makes sense.
And since you can't dynamically change your body mass in the middle of a swing, manipulating this ground reaction force in both magnitude and direction is the singular way to forcefully move your body.
Okay, I have to push back on the application of that, though. Because if the goal is maximizing force against the turf, wait, so I'm pushing the earth and the earth is pushing me. Does that mean the harder I stomp my feet, the further I hit the ball?
Well, no. A purely vertical stomp only drives energy straight back up through your spine.
Oh, right, like a jump.
Right. We need rotational power, not vertical leaping. There was this great 2019 study on women's driver shots by Atsushi Okamoto that gives us the exact directional vector we need.
The one with the 10-camera 3D motion capture?
Yeah, synchronized with dual force plates. And they discovered that the key isn't just downward force. There's a strong correlation between the frontal plane moment about the center of mass and maximum club head speed.
Okay, we definitely need to translate frontal plane moment into functional swing mechanics, because that sounds like an engineering exam.
Fair enough. Functionally, it is a twisting torque. So imagine a steel steering column running vertically through your torso.
Okay, I'm picturing it.
By pushing both laterally and vertically against the ground with your feet, but in opposing directions, you create this massive rotational torque around your body's center of mass.
Oh, wow, so you're twisting the steering column with your feet.
Exactly. And Okamoto found that elite golfers max out this twisting force at around 78.3 Newton meters. That torque travels up through your core, converting that static ground pressure into the violent angular momentum of your thorax.
And that perfectly outlines the bottom-up kinetic chain. The energy originates in the turf, travels up the legs, into the pelvis, up the torso, down the arms, and eventually snaps into the club.
Right. But the actual mechanism governing that energy transfer is what we call the X-Factor.
The separation between your upper torso and your pelvis orientation.
Yes. According to the research, it's not just about turning. Rotating your body as a single synchronized unit just bleeds power. The segments actually have to fire independently.
So the traditional coaching metaphor here is always wringing out a wet towel. Your hips turn one way while the shoulders temporarily resist. But mechanically, that feels a bit inadequate, right?
It does. A much better biomechanical model is winding up a tightly coiled torsional spring.
Relying on the fascial stretching.
Yeah, the torsional spring model is vastly more accurate because it accounts for muscle loading. There was a study analyzing elite professional golfers that measured the linear velocities of the upper torso and the pelvis during the downswing.
And they found a really high coupling strength, right?
A staggering coupling strength of 0.86 between those two segments.
Wow. A correlation that high suggests like almost a perfect sequence of energy transfer.
It really does. The researchers noted that the pelvis always leads the upper torso in the anterior-posterior direction. So in real terms, your lead hip fires backward away from the target line, while your trail hip drives forward,
Initiating that rapid pelvic rotation.
right, but your upper torso dynamically resists that initial lower body movement. That resistance stretches your core musculature incredibly tight, loading that physiological spring before it aggressively contracts.
And that brings up a critical point from the data about the timing of that release, because you can build this massive torsional spring from the ground up, but you can still lose all that energy before it reaches the ball.
Oh, absolutely. The data shows that the highest ball velocities correlate with delaying the final release of your arms and wrists until the absolute last moment.
Specifically, the last 40 milliseconds before impact, which is just, 40 milliseconds is less than the blink of an eye.
Yeah.
How does a golfer consciously control something that fast?
Well, it's really about the preservation of angular momentum. By maintaining the angle between your lead forearm and the club shaft, which is what golfers call lag, you keep the mass of the club closer to your center of rotation.
Oh, like an ice skater pulling their arms in to spin faster.
Exactly. In physics, a smaller radius allows the system to spin faster.
Yeah.
The moment you unhinge those wrists, the kinetic energy transfers rapidly from your body out into the club head. Doing that in the last 40 milliseconds ensures maximum acceleration directly through the strike zone.
Rather than decelerating before impact.
Right.
Given that really precise kinematic blueprint, the common mistakes amateurs make become pretty obvious. Like James Parker's coaching notes highlight this persistent confusion between two critical words.
Weight and pressure.
Yes, the ultimate amateur mistake, swaying.
Yeah, swaying is when a player physically slides their hips and head their actual mass horizontally over their trail foot during the backswing. Elite players just do not do this.
Hold on, so I shouldn't, quote-unquote, shift my weight back on the backswing? Because that contradicts literally every piece of unsolicited advice I've ever gotten at a public driving range.
I know, but the force plate data systematically dismantles that advice. Pros actually address the ball with about 55% of their mass biased over their lead foot.
Okay, so already starting slightly forward.
Right. And at the absolute top of the backswing, that mass shifts to maybe 60% over the lead foot.
Wait, so they never really shift their mass backwards at all?
Exactly. And by impact, they end with a massive 80 to 95% of their mass over the lead foot. The physical mass is essentially forward biased for the entire swing.
That is mind-blowing. So what are they doing with the back foot then?
They load pressure into the trail foot halfway back to generate that twisting torque we talked about, but their actual weight, their center of mass, stays relatively centered. The spine tilts and extends in 3D space to act as a centered pivot.
Wow, so if you sway your physical mass backward, you're just doomed.
Pretty much. Physics dictates you simply won't have the time to drive 90% of your mass back forward before the club head meets the ball. You end up hanging back, disrupting the low point of your swing and losing all that kinetic energy.
So now that we know what not to do, how do we actually train the right moves? Especially since the real world isn't a perfectly flat driving range mat.
Well, there's a fascinating 2024 preprint by Belotti's team on the Ground X-Factor. They tackled this through proprioception training.
Proprioception, so like the body's subconscious ability to sense its position in space.
Yeah, exactly. They didn't just give golfers abstract swing thoughts. They had them train a specific rhythmic sequence of forefoot and rear foot pressure and shear forces.
So consciously training the central nervous system to use the cleats to grip and shear the turf before they even hit the ball.
Yes, and it drastically improved their lead foot peak vertical force, their club speed, and their ball speed. The power genuinely originates from the cleats up.
But of course, we also have to adjust for the reality of golf courses, like playing on slopes, The Blankensop study explored this, right?
They did. They put golfers on these dynamic platforms that simulate uphill and downhill lies, and they found that slopes fundamentally alter your baseline kinematics by changing your center of pressure.
How much of a change are we talking about?
On a downhill lie, the center of pressure shifts about 9.4% closer to the front foot. On an uphill lie, it shifts about 8.9% closer to the back foot.
Which heavily disrupts that standard kinetic sequence. So, from a practical coaching standpoint, you have to warn the listener, you can't just take your flat ground swing to a severe slope.
No, you really can't. An uphill lie inherently increases your launch angle and encourages ball spin to the left, which increases the risk of a hook.
And a downhill lie encourages spin to the right, promoting a pull fade.
Right. You have to adjust your strategy and alignment based on the physics of the slope.
It's crazy because historically, measuring, a 9.4% shift in pressure or tracking a 40 millisecond wrist release, that required a multi-million-dollar lab.
Oh, absolutely. You'd have to be covered in reflective markers standing on heavy force plates, but that is changing so rapidly.
Yeah, the 2015 Najafi study proved that. They successfully used a simplified wearable sensor model to track a golfer's center of mass dynamically.
Without needing bulky pressure plates. And they made a critical distinction. The center of mass moves 10 to 12 times more than the center of pressure. So tracking the mass via wearables provides immediate feedback on whether you're improperly swaying.
And then you have systems like Gear Sports, using 3D motion capture to track absolute positioning with zero drift, down to 0.2 millimeters of accuracy.
The fidelity is just staggering.
It's like going from needing a NASA control room to having mission control right on your belt.
It really is.
So let's distill all this heavy science into some core principles the listener can actually take to the first tee.
Sure. First, power is harvested from the ground up via ground reaction forces.
Right. Second, separate mass from pressure. Load the trail foot with pressure, but do not sway your mass backward. Keep that centered pivot.
Third, maximize the X-Factor. Create that dynamic separation between your pelvis and your upper torso.
And finally, number 4, delay the release of your arms and wrists until the absolute last 40 milliseconds before impact for maximum speed.
That's the blueprint right there. The golf swing really is a masterful manipulation of physics. By understanding these concepts, any golfer can bridge that gap between amateur struggles and professional power.
Which brings up a really provocative thought about the future. If wearable tech will soon just instantly vibrate the moment your center of mass sways even 1 inch too far off your trail foot, will the golf swing eventually become this automated robotic reflex?
That's the million-dollar question. Or, will offloading all these mechanics to a computer actually free up the golfer's mind, like enabling them to become purely artistic and target-focused on the course?
Wow, something to mull over on your next trip to the range. Well, if you enjoyed today's deep dive, please subscribe to our channel and share it with fellow golfers, coaches, and PGA professionals. If there's a topic you would like us to research, analyze, and discuss in a future deep dive, feel free to send us an email or connect with us through LinkedIn. Whether your interest is golf biomechanics, kinematics, ground reaction forces, swing mechanics, putting, coaching, club fitting, technology, or sports science, we would love to hear from you. Our team will review your submission, conduct extensive research, analyze the available evidence, and may create a dedicated deep dive, article, video, or testing project based on your topic. Thank you for being part of the eCoach 360 Degree community.